In this lesson, we look at arithmetic series, and arithmetic series are just the sum of the terms in an arithmetic sequence. So that's the definition of an arithmetic series. For instance, if you add 1 plus 4 plus 7 plus 10 plus ... all the way to 40, that's an arithmetic series because all the terms in the series are are consecutive terms of an arithmetic sequence. So let's do a fairly straightforward problem. In this problem, we're told determine the sum of the first 100 natural numbers. So if you have a calculator, you can probably do this, but it's going to take some time. And maybe you can do it without a calculator, but again, it's going to take quite a while. So there's actually a story that goes along with this problem, and it's a story where there was a young child in an elementary math class, and he was told to add, he was told this exact same problem, determine the sum of the first 100 natural numbers, and pretty much immediately he answered the teacher. He threw up his hand and he answered the teacher, and he said that the answer was 5,050. The teacher was shocked and a little bit disappointed because she or he had hoped that the problem would keep this child busy. The story is that it was Carl Gauss that was the pupil in this anecdote, and there's a little bit of debate as to whether the story is actually true or not. But it makes for a nice anecdote and introduction to arithmetic series. So let's look at the pattern that Carl Gauss supposedly noticed when he was summing the first 100 natural numbers. So the first thing that he noticed was that if he called the sum of the first 100 natural numbers, if we called that S, and he added 1 plus 2 plus 3 plus 4 plus ... all the way to 100, well, he noticed that if you add all the terms in the arithmetic series in reverse order, and you write this as 100 plus 99 plus 98 plus 97 plus ... all the way to 1, we have the same series written in the reverse order. So if I add both these series together, I would have that 2 times the value of the series is equal to, well, let's see here, we would have 101 plus 101 plus 101 plus 101 all the way to the nth term, which would be 101. So we would just be adding 101 100 times because there's 100 numbers in this series, and I've just added 100 of these terms together. So and all of them are equal to 101. So we would get that 2s is equal to 100 times 101, because repeated addition can be written as multiplication. If I'm adding 101 100 times, that's the same thing as 100 times 101. If you divide both sides of this equation essentially now by 2, you get that our sum is equal to 50 times 101. And so the sum, S, is equal to 5,050. So therefore, the sum is 5,050. Now we can extend this. Problem 2 says determine the sum of the first n natural numbers. So let's see if we can extend this, not just summing the first natural numbers from 1 to 100, but let's extend this to summing the first n natural numbers. So let's go ahead and we'll write out what this sum would look like. We would be summing 1 plus 2 plus 3 plus 4 plus 5. Let's just write out to 4. That's probably enough. Plus n. And then we could write this out in the reverse order. I could write this as n plus n minus 1 plus n minus 2 plus n minus 3 all the way down to 1. So let's again call this the value of this series s. So we have that s is equal to 1 plus 2 plus 3 plus 4 all the way to n. And then we've got that s should also be equal to n plus n minus 1 plus n minus 2 all the way down to 1. And we can do that because addition is commutative. So it means that the commutative property says that a plus b is equal to b plus a, and that's the commutative property for addition. So if we add these two series together, we have that 2 times the value of s is equal to, let's see here, if I add n and 1, I would get n plus 1. If I added 2 and n minus 1, I would get n plus 1. If I added 3 and n minus 2, I would get n plus 1. If I added 4 and n minus 3, I would get n plus 1. And I would have that this n plus 1, n plus 1, n plus 1, all the way to n plus 1. Okay, so the question is, how many times have I added n plus 1? Well, here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to n. So there's n numbers here, or there's n terms here, and there's n terms here. So then I should have that there's, I've added n plus 1 n times. So I get that 2s is equal to n times n plus 1, and thus s is equal to n times n plus 1 over 2. So therefore, the sum of the first n natural numbers is n times n plus 1 over 2. Okay, so any number that can be represented by the sum is actually called a triangular number, and we'll talk about that in the next video. So both of these series that we just summed, the sum from 1 to n and the sum of the first n natural numbers, which is kind of just extending problem 1, both of these series are arithmetic series because there's a common difference between all the terms. Now let's see if we can extend this problem that we just did to, let's see if we can extend this to problem 3, where we have a plus d plus a plus 2d plus a plus 3d plus ... all the way to a plus n minus 1 times d. So this series is an arithmetic series. It's an arithmetic series that has first term a, second term a plus d, third term a plus 2d, fourth term a plus 3d, and nth term a plus n minus 1d. Remember that the nth term of an arithmetic sequence is a plus, where a is the first term, a plus n minus 1d. So that's the nth term in an arithmetic sequence. It's also the nth term of an arithmetic series, because in an arithmetic series we're just summing the terms in an arithmetic sequence. So what I have here is I've got the sum of the terms of an arithmetic sequence. So let's try to implement the method that we let's try to implement the same method that we implemented above to come up with a formula for summing the first n natural numbers. So what we did up here was we added all of the terms in reverse order, and we called this value s. So let's say that, let me just write this out a little bit nicer. So we've got s is equal to a plus d plus a plus 2d plus a, let's just, that's probably good there, plus ... plus a plus n minus 1 times d. Now there's n terms in this entire sequence here. We have n terms. That's something to take note of, and we'll call this series, just like we did above, we'll call it the value of it s. And just like we did above, we're going to rewrite this series in reverse order. So the last term, now I'm gonna write this as a plus n minus 1 times d plus the term before that would be a plus n minus 2d plus a plus n minus 3d plus dot 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 plus a. We're going to add this all the way down to a. So now I can see that that all of my, if I add all these terms together, and I add these two series together, I have that 2s is equal to, well, let's see here, I would have a plus a, which is 2a, and then if I add to a, if I add to 2a, n minus 1d, I would just have 2a plus n minus 1d. The next two terms, I would have 2a plus, let's see, d plus n minus 2d is just going to give me one more d, which is going to be n minus 1d, because 1 greater than n minus 2 is just n minus 1. So I would have n minus 1d plus 2a plus 2d plus n minus 3d. And if I added 2d to n minus 3d, I would just have n minus 1d. And you guys can kind of see what's happening here is that all of these values are all these values here are the same. So I've got 2a plus n minus 1d was what happened when I added these two terms together. And then I had 2a plus n minus 1d is what happened what I got when I added these two terms together. And then when I added the next two terms together, I had 2a plus n minus 1d. That pattern is going to continue until we get to the last two terms, the last two matching terms. So we would just have plus 2a plus n minus 1d. And again, we get the same thing. So the question is, how many times have we added 2a plus n minus 1d? Well, there were n terms in this original series, and there's n terms in this series, and we matched them so that each of the two matching terms added to 2a plus n minus 1d. So there should be n of these terms. So we have that 2s is going to be equal to n, because since there's n terms, I can change repeated addition to multiplication. I have that 2s is equal to n times 2a plus n minus 1d. If I want to isolate for s, I can just divide both sides of this equation by 2. So I get that s is equal to n times 2a plus n minus 1d. All divided by 2. Now, what this does is this gives us a this equation that I've just or this sum that we've just written down here is a formula that's useful if we if we're given an arithmetic series. We can write the sum of that arithmetic series as the product of the number of terms times 2 times the first term plus the number of terms minus 1 times the common difference divided by 2. That's an extremely useful formula, and we're going to make use of that in the next few videos. Now, another way to write this is to split up 2a I could rewrite this as, this would be equivalent to n times a plus n minus 1 times d, all divided by 2. Now, something to notice is that a plus n minus 1d is the nth term. It's t sub n. So I can rewrite this formula as n times a plus t sub n, all divided by 2. And that's another formula that is useful to know, is that if you're only given the first term, the nth term, and the term number of the nth term, then you can jump right to this formula, and you don't need to know the common difference.